All right, so today we're going to be talking about when a line is tangent to the circle. So tangent means that it's going to be going right along the circle and it's going to form a right angle where that line hits the circle. So if we look here at the example at point P, so angle APO is 90-degree angle inside the circle. So that's going to be useful when we're doing some of these problems. So it says DE is tangent to O at D, so find X. So again, if it's tangent to the circle, wherever it's tangent at that point, it's a 90-degree angle. So there's a 90-degree angle here, and then we just have a regular triangle. So triangles equal 180 degrees. So we're going to do 180 minus 90 minus 38, and that's going to give us 52 degrees for X. When we have triangles, we're going to do Pythagorean theorem. So to find the missing angle, so we need to find the side. So we're finding the radius, which is X for both sides. So again, the hypotenuse is always across from the right angle. So that has to be our C. So we've got A squared plus B squared equals C squared. So first we have X squared plus our other side that makes the right angle is 12, and then equals X plus 8 squared. So this here, it's not multiplied, it's addition. So we write it as X plus 8 squared. So then we have to FOIL everything out. So this is going to be X squared plus 144 equals, now this becomes X plus 8 times X plus 8. So anything squared is times itself. So we do first, so we get X squared plus 8x plus 8x plus 64. So when we combine like terms here in the middle, we get x squared plus 16x plus 64. If you want to do the shortcut, you can do that where you do 8 times x gives you 8x, double it, gives you the 16x, and then 8 times 8 is 64. If you can remember that shortcut, you can do that way as well. If we look here then, our next step, we have an x squared and an x squared on both sides. So these are going to cancel out. So we're going to be left with 144 equals 16x plus 64. Subtract 64 from both sides. So we get 80 equals 16x, and divide by 16, so we get x equals 5. So what I would like you to do is pause the video, and you're going to do this next problem on your own, and then when you're ready, unpause it, and it will show the answer. So go ahead, check your work for the problem that you tried, fix any mistakes that you had, so you make sure you have the correct answer written down. So next we're going to show that line LM is tangent to N at L. So again, we're trying to show that there's a right angle here. So in order to do that, we just have to show that A squared plus B squared equals C squared. So we have 7 squared plus 24 squared equals 25 squared. So again, we're just checking to see if this is true. So 7 times 7 is 49 plus 576 equals 625. And 49 plus 576 is 625. So since they are equal, then yes, it is tangent. If they were not equal, then it would not be tangent. And then our last example is finding the perimeter. So we have this other theorem here that says if they are tangents, then the segments are going to be congruent. So that's saying if AB was 8, then BC is also going to be 8. So we're going to use that here in example 4, where we have to find the perimeter of the triangle. So we're missing this side, we're missing this side, and we're missing this. So in order to figure that out, we're going to use a theorem that says that it's congruent. So AD is going to be congruent to AF. So AF is also going to be 10. FC is going to be congruent to CE. So that's going to be 8. And then DB is gonna be congruent to EB, so that's gonna be 15. And again, that's just using the theorem that says that those segments are gonna be congruent if they are tangent to the circle. Then to get perimeter, you add everything up on the outside. So we're gonna have 10 plus 10 plus 15 plus 15 plus 8 plus 8. So when we add all that together, we get 66 and it'll be centimeters for perimeter.